So today I'm going to explain how the Pixi-viewport Drag event or drag plugin works. I'll try my best to explain in the way that I understand now. And then after that I'm going to talk about some stuff that I've been thinking about physics and symbols and perception. And for the stuff about physics I'm going to take my time because I still don't know what to make of these things that I'm thinking about, and I don't know if they make sense or not, but I want to share them. And yeah. So let me start with the Pixi-viewport thing. And the feeling that I got after I understood the Pixi-viewport drag is that I don't really like the way that they did things. It feels to me that there must be a way that is easier, and there's like two main things I think that didn't make sense to me. The way that they did it. So I'm gonna try to explain. This is the stuff that I did related to. So I wrote down all the variables that they use, and wrote down all of the events and the sequence. First, I was doing the sequence of events, but then I decided to just write down the variables and then write down the events and see how they connect all of them. So see which variables are being used to each event. So here's like the sequence of events that happen when each event triggers. So for each one, what happens is that you have the down event, the move, and the up. And for each one, the function that gets triggered first is the input manager function. So before any of the functions on the Pixi-viewport get triggered, the Pixi event system gets called first, and then there's a bunch of functions that it runs to decide if what events are going to be triggered from that. It calls a function that is a heat test to see where the mouse position is at, and then what thing on the visualization was hit by the event. And then based on that, it calls the functions on the listeners. And then the first function that calls is the function that is on the input manager, which is the main function for each event. And then inside of that function is going to call the function on the plugin manager, which is this function in the middle here. And then the plugin manager is going to loop through all of the plugins that are currently activated, and is going to call the event if the plugin has the function. So for example, if it's a down event, then it's going to call the down function on the plugin manager, and then it's going to loop through all of the plugins that are activated, and it's going to check if the plugin has the function, and if it has, it's going to call the function on the plugin. So as is doing all of this stuff, there's a bunch of flag variables that are going to signalize whether or not it's the correct time to trigger the event or not. And this is probably the main reason why I thought that this is probably not optimal, and there's probably a better way to do this. But one of the reasons why they do it like this is because they have to maintain the flexibility, so that depending on what the person that is going to use the library wants to do, they have to like keep that in mind. So I think that's one of the reasons why there's a bunch of flag variables, and it gets very confusing. But yeah, so let me go to the code. Pretty much what I realized is for my use case, the input manager function is irrelevant. You don't really need it because they have these flag variables here, and like a bunch of them are set up on the options, which is the object that you pass when you initialize the Pixi-viewport, and the default ones are always going to be true or false. So like the condition is always going to pass, and the other ones, they don't change the variable at any parts of the system. So at least from what I know, so I don't understand, like these checks here seem to be irrelevant to me. Like I'm sure that some circumstances is relevant, but I couldn't figure out when. This other stuff here, the clicked available, I think is a flag variable that manages the events based on the input manager, but also I thought that is not very useful. Like I didn't really see the point. I could just use this dot last, and this dot last is the last position of the mouse. So it's going to cache the position at the point that the mouse down event happens, because it's going to use that position for the mouse move to calculate the distance that it has to move the canvas. So, and then this stuff here, these two different functions are for checking, because they allow you to put an option that is going to determine when is the mouse move events going to happen. So by default is 5. So that means that if you click the mouse and then you move and that distance is less than 5, then it's not going to trigger the functions it's not going to trigger the calculation that moves the canvas. And so it's pretty much a threshold for when to activate the calculation that is actually going to move. So this is kind of useful, but also I didn't like very much the way that they did this. I think that the biggest thing that I don't understand why they did it, and it seems to be irrelevant, is that in a bunch of parts of this code, they use this emit function here, and they emit these events, but it seems like for the most part, the events are not gonna, there's no part of the application that is listening to the events. So I really don't understand why they put this. And also, like, what this does is that it makes you think that the event system in Pixi is listening to these events, which I think is not the case also. So for someone that doesn't understand the Pixi event system, it kind of forces them to go over the Pixi event system and try to understand everything that happens, because they are putting this here, and it seems like there's no there's no functionality that is attached to this. So I really don't understand why they did it like this. So in my mind, if you're gonna put this and you're not gonna use it, then you should put a comment that explains why this is here. So I don't understand. Maybe there is maybe this is useful for some reason, but I don't get it. And the biggest thing that I thought it was weird as well is that on this part here. So after it calls the mouse, the event here, let's go to the down event first. So I'm going to go to the down, then move, then up, which are the 3 events that are related to dragging the canvas. So this count function here keeps track. This is another thing that I kind of think is weird, that pretty much all that this function does is check to see if the mouse down flag variable is true. If it is, then this function is going to return 1. And also, another reason is because they have the pinch event. So if you have every time there's a pinch event, they're going to keep track of how many inputs the thing has. And so pretty much it keeps track of how many mouse downs exist. It's kind of hard to think about good way to say it in English, but how many points of contact, let's say, that there are on the screen at the moment. So this is pretty much for the pinch events, basically. So the mouse down keeps track of whether the first time that you click, and this touch length here keeps track of the other times if you're using the smartphone. So this function returns, if it returns more than 1, that means that is a pinch event. Then if it returns 1, there's a mouse down, as far as I understand. So they have 2 different variables that do pretty much the same thing, which is mouse down and the function. And this function and the mouse down are used on the other ones to see if other logic is going to run or not. Which I think that there might be a better way to do this by just using the isMouse down, and instead of calling the function each time, you just make the isMouse down to be equal to 0 or something like that, and then you increase the value each time. So I don't understand, because the thing is that if you do it with the function, it gets confusing, because then, like, sometimes you're using isMouse down and then sometimes you're using the function, and it's not, I don't know, I thought it's very confusing to understand what's going on. So the click available thing here, I think, is pretty much is a flag variable that keeps track of whether or not the decelerate plugin and the bounce plugin are activated. And if they are, then it prevents the other logic to work as well. So I think this is fine, but yeah, for my use case, I'm not going to use this for now, I think. So it's another stuff that I could remove. And I'm going to show after I removed everything, how like more simple it becomes. But like I said, like a lot of this complication is because the overall architecture of the thing. So I kind of understand it, but there's some things that I think that even even if you have to take care of the architecture, I don't see the point of having. So I pretty much here, okay, so it goes through these flag variables that are going to decide whether or not the event is going to activate, and then the stop here is where it calls the down function on the plugin manager class. And then on the plugin manager is going to loop, and it does this for all of the other events as well. It loops through the plugins and then calls the down function. So I'm just going to focus on the drag plugin. I'm not going to explain the other ones because the drag is the one that I'm doing now. So, and there's a lot of stuff in my mind. So it's kind of hard to explain, but I'll try to be fast. And yeah, so these two different functions as well is pretty much for flag variables also. So this function uses the count function from the input manager, which is the function that keeps track of the is mouse down. So it pretty much checks to see if there was a click event already. And if there is, then this condition passes, and then it initializes the last mouse position, which is in this variable. And this current, I think it just keeps track of which event it was. Which also I think that is not very useful, but maybe it is this one I'm not really sure. And then this one does pretty much the same thing. It just keeps track through the flag variables of whether or not there was a click event or mouse down event before. If there is, then it caches the position. So for the mouse move stuff, does the same thing, calls the mouse move here, and it's not that important because most of the variables are just flag variables to check whether or not to call the functions, and then it calls this one. So this one is true by default, so it's always going to be false here by default, and the other one is the other one that I couldn't find any reason to have this, so I just removed this part. I don't think it's very useful. And then here I removed the this current as well, which is the one that checks to see which kind of event it is. I don't see the point as well. And then it checks to see if there is the last mouse position, which is the only one that I think it makes sense to put there. Because if there is a mouse, this.last variable, then it means that there was a click event before. So the logic of the move event should run. And I think that the biggest part that I think that is unnecessary and I don't see the point of having is on this line here. So this moved is another flag variable that they use to check to see if the logic is going to run or not, which I don't understand because you already have the this.last here. So this doesn't make sense to me to have this variable here. And here, these two functions, yeah, this function here is used to check the threshold that I talked about, which is going to be 5 by default. So if the distance is less than 5, then it's not going to run the functions because this is going to return false. And if the distance that the mouse moved is greater than 5, then it calls these functions, which makes the canvas drag. And pretty much the main thing that this does is only these two lines here. Everything else is just extra code with a bunch of flag variables to take care of checking whether or not you should call these functions here. So, and this is the stuff that I mean that after I figured this out, I thought that there must be a better way to do this because like either to document everything more or to remove a bunch of this stuff because it gets very confusing and like you have to study all of these other things that are not related to the event itself just to understand what's going on. So like the main thing is these variables here as well, which they are true by default, I think, and they're part of the options. So I don't really understand why put them here because you're already checking here again to see. So from as far as I understand, the reason why they have these variables is so that you have the option to decide at what position you're going to translate the canvas. So maybe you want to translate the canvas only on the X direction, then you would put the other one as false and vice versa. But I don't understand like why put them here, like, because you could just ask for the check here, the threshold, and then check for the positions here, because you're already doing that anyway. So I really don't see the point of this condition here. And then here again is another thing where I couldn't find any place that listens to this thing here. But pretty much like the main thing that it does is just changes the x and y from the parent, which is the viewport, which is the container, by this amount, which is going to be the amount that the position that the mouse is at on the inside of the move event, and the last position that the mouse was at, which happens on the mouse down event. So when you click on the canvas or on the object on the Pixi-viewport container, it's going to keep track of that position, and then every time you move, there's going to be this distance, which is the delta from where the mouse is currently at and where the mouse was at the point you clicked. And then it's going to change the x and y direction of the Pixi-viewport container by that amount. So if you want the canvas to move, you also have to put everything inside of the Pixi-viewport container. Otherwise, the container is going to move, but if you render the visualization on the app.stage directly, your visualization is just going to stay on the same place because it's not inside of the container. And then that's pretty much it. And then they change the last to be this, so it updates the delta, I think. And the rest is just flag variables. And then on the up event, the main thing that they do is just make this dot last equals to null. And then this logic here is just for the pinch event, which I'm not gonna focus on right now. But most of this stuff is irrelevant, I think. So yeah. And I feel like I have to be real, because that's how I felt when I did this stuff. Now, obviously, like, it's a bonus because they're providing the library for free, so like I don't want to shit on them, but at the same time I have to be real, and because that was the feeling that I have, like, fuck all of this stuff, and the actual thing that does the event is very simple, but because there's all this extra stuff, you have to waste a bunch of time to understand everything that is going on. So it kind of pissed me off. And the actual event, and I tested this, but I'm having some problem, and I think I might study the event system to figure out why. But I'm going to explain after I show like the version that I have here, which is after removing all the stuff that I thought is unnecessary. So pretty much what happens is on the down event, all you have to do is set the last position. And then on the move, you check to see if the last exists. If it exists, you change the x and y by the amount. You change the x and y of the parent by the amount, which is going to be the x and y of the current event minus the x and y of the... No, the x and y of the current event minus the x and y of the position where the mouse was at when you clicked the canvas. And then on the up event, you just... I think I left the touch, but you just make the last position equal to null. That's pretty much it. It's very simple, actually. And the problem that I'm having is that if I set up these events on the canvas, then the positions are messed up, because the way that they do it is on the event system, they get the events that happen on the DOM element, and then they do some modifications to that event in order to be part of a class that is from Pixi. So they are pretty much adding functionality to the event, so that is a more accurate representation of what's actually happening inside of the canvas. So you have the local coordinates of x and y, and it's more... I still don't understand really well. I think I might study this now. But what happens is that when you use Pixi-viewport, I don't know how exactly, but the event is going to be triggered by the event system from Pixi. So the argument that they receive here is different, which makes it so that they have access to the global attribute of the event, which contains the position, the x and y position of the element, I think. And if you try to put the event directly on the canvas, then the problem is that you have to figure out how to get the relative position. Because the problem that I'm having is that when I click and try to drag, the canvas just goes way out of the screen. And this is because I'm using the offset here, because I was just trying to test to see if it's going to work. And then I'm changing the app stage instead of changing the Pixi viewport. Because that way I don't need to keep, because I don't want to use Pixi viewport anymore. I just want to do it on my own thing. So I'm trying to change the container from app.stage, which is where everything else is at. And then because I'm using the X and Y as the offset from the event, the canvas just goes away. And then when I try to set up the events on the container instead of the app.stage, or on the app.stage instead of setting up directly on the canvas, the events don't trigger for some reason. So I'm trying to understand why that's the case. And I think it has to do because of the way that the event system sets up the listeners for the events. So when the event system is created, it creates another class called event boundary. The event boundary is going to manage the events that Pixi has. And then every time an event happens on the canvas, it's going to call the event system first, and then it's going to call a function from the event boundary called map, and then whatever the name of the event is. And that function is going to call, is going to check to see, is going to loop over a table that the event boundary has, which maps the event name to an object that contains a function that's going to be called and the priority of the function. So when you use Pixi viewport, it finds out, figures out that the Pixi viewport is a listener, and I think it does that by the hit test recursive function, which is a function that checks to see if the event happened inside of an element of the canvas. And then if it does, I think it creates an attribute on the event boundary class that represents the listener, let's say. And then based on that, it's going to call the function on the listener. But for some reason, if I do it by passing the app.stage here or the container, and I try to set up these events directly on the app.stage or the container, they don't work, because I think that the event system and event boundary can't find them on the listener. So I'm trying to figure out if I can use those classes directly, call some function from those classes to manually add the app.stage or the container, so that these functions that I have here get triggered through that process, and I receive the event from Pixi and not from the DOM. And that's going to allow me to have access to the global attribute, which is going to give me the right position here. I can either do that, or I can just figure out how to calculate the position so that it is an accurate representation of where the mouse is and calculate the delta correctly. And I think that's going to work. So that's pretty much it, I think. Hopefully I don't forgot anything, because there's a lot of stuff going on. And this is how all of the events. And here the thing is that I couldn't specify more because it was just going to be too confusing to separate in a bunch of different functions. Like here I'm putting together all the down functions that happens throughout all the different classes, and then I'm just putting arrows to what variables they access for each one, for each event. And then I use this a little bit to see what variables are called by all of the functions that are related to the drag event, which are these ones. And then here I wrote down a bunch of stuff of what parts I didn't think I would need for my case. But it's a lot simpler than I thought it would be, to be honest. And then the other stuff that I think is worth talking about as well, which is not related to Pixi viewport, is that if you want to create a drag event, so let's say you have elements on the canvas and you want a different functionality to happen, whether the click happened inside of an element or outside, then what you do is just set up two different flag variables. And then based on that, you're able to determine. So here what I did is that first I loop through all of the nodes on the canvas. And if the event happened on the node, then it's going to return here. And I also have this other variable. So if the event happened inside of the node, it's going to make isDragging equals to true, which is not going to set up the last mouse position. And because it doesn't set up this is going to be null inside of the move event. So in the move event, I put this condition to check if it's different than null, because if it is different than null, that means that the event didn't happen inside of one of the nodes, and then I can change the position of the canvas. But if it is null, then I check to see if it's not dragging, and here I'm not really sure if this is even needed now, because it's either going to be one or the other, I think. But maybe, yeah, it doesn't matter that much to leave there. And then if both of these cases are not true, that means that the event is on inside of one of the elements, which means that I change the functionality that is going to happen. And here I'm just changing the forces on the node so that it changes the direction. But I still have to figure out some stuff related to this, which I'm going to figure out after I figure out the wheel event for Pixi, and I figure out how to put on the actual events these things here. How to actually receive the event from Pixi and not from the DOM here. So I have access to the variables that they use to change the container. And going through all of this, I think also makes me want to create my own library instead of using Pixi, because I feel like if this didn't resonate with me the way that they did things, because it feels overly complicated, then there's probably a bunch of other stuff on Pixi.js as well that I'm gonna have the same feeling. That the way that they did things, for my use case, it doesn't seem like it is the best way to do it. There's a bunch of stuff that I think I can get rid of and make everything a lot more simple. But it's gonna take a bunch of time, I think. Yeah. I think that's for Pixi. It's probably everything that I wanted to talk about. And now I think I'm gonna talk about the stuff related to physics that I'm still thinking about. And I thought it was really interesting. I spent a bunch of time thinking yesterday about this, but I'm not really sure if it makes sense or not. But I feel like I have to share on my YouTube channel, because I think that is somewhat interesting, and it's probably I think it's definitely gonna be related to AI alignment and building a blockchain in the future. But it's very difficult to think about. I think I'm gonna be right back, take a break, and then when I come back, I'm gonna talk about this. Let's see if I miss anything. A lot of these variables as well is just options to change the way that the events are gonna work. And to be fair, some of the variables as well are related to the decelerate event, which I'm not gonna use for now. So I think that it might be the case that you can't really simplify that much as I did there, because if you want to do the decelerate event, you need other variables. And also if you're trying to maintain flexibility, because you're creating a more general library, I think it might be the case that you can't really simplify the variables as much. So I don't know. Yeah. But I think for my way of thinking about things, it seems like the feeling that I get from study Pixi, not just Pixi-viewport, but Pixi.js, is that a lot of the parts are overcomplicated. That's the overall general feeling that I have. So I'm gonna draw this stuff about physics here. I think I want to talk about these things so I can clarify my mind as well, some stuff. See if I can make sense of the stuff that I'm thinking about, or if it doesn't make sense at all. Actually, it might be better to just do them on separate things. I'll be right back. I think I'm gonna take my time to try to explain this. But if you're someone that is listening to this at some point and you feel like you understand what I'm talking about, and maybe you have a different perspective or explanation on these things, I would be very interested to listen to what you have to say. But I think it's very hard to find people that are gonna understand the place I'm coming from with this. And maybe what I'm talking about doesn't even make sense as well. I'm not really sure, but yeah. But if this stuff makes sense, then I think it's very profound. Because it should uncover some secrets about reality, maybe. But it's hard to know if it doesn't make sense at all. Or it's very possible that it's like not as deep as I think it is. Just put some random letters. Oh, actually, I should put letters that creates a word. Put cats or let's see how much I can go as well. So I have to remember the the sequences of thoughts that I had to think about what I'm thinking. And some of these I tweeted as well. Fuck. Maybe I won't do it on all of them. It's annoying to draw this stuff. I think you can get the point here. Just with a few of them. Okay, so pretty much what I was thinking is that I was thinking about how binaries become language. And I think that the structure of language itself, not just programming language, is done in the same way, is the same logic. So yeah, the way that this happens is through a convention. So there's nothing that's there is something that determines, which is the convention. But maybe I should explain this first, and then I think about I talk about what do I think the convention is. But the way that the binaries become language is through a convention. So you have a sequence of zeros and ones, and that zeros and ones become a character based on the convention. And then you can use a bunch of sequences of characters to create other to create words, and then you can use words to create sentences, and you can use sentences to create paragraphs and so on. So the structure of concepts is related to the symbolic representation of them, because that's what concepts are. Like they are nested hierarchies of these structures here. So if you think about it, 0 and 1 are just symbols. Like a 0 is a symbol and 1 is a symbol. So all that is happening is that you're using two different symbols in order to create a construct that is going to attach meaning to another symbol based on those two different symbols. And then from the symbols that you get, you put together more symbols, and then you do the same process. So like it's kind of a fractal pattern that you're using symbols to build on top of symbols. And the reason why you do this is to compress information, because it's more efficient to think about A instead of thinking about a collection of zeros and ones. But then if you think about it, and this is the stuff that kind of broke my mind a little bit, is that I was thinking about why isn't the process on the reverse order? So why, instead of doing things like this, you don't use the words to create the binary? Because in my mind, the way that I'm thinking, the way that I'm currently thinking about things is that, and this comes from a thought that I had a long time ago, which is about the structure of mathematics. That the way that I think about is, how can I do that? Let me put just a really, imagine that this is infinity. So the way that most people think about, I think, is that the distance from 0 to 1 is smaller than the distance from 0 to this large number, which is infinity. But the way that I'm currently thinking about is that the distance is always the same. What changes is not the distance. What changes is our perception over the distance. So mathematics is a symbolic representation of the structure of your perception. And distance, I think, is a bad word, because maybe the distance is correct to say that the distance between 0 and 1 is smaller than the distance between 0 and a very large number. But I think that what keeps the same is the potential that exists, and the potential is infinite, because the potential of all the parts of experience are always infinite. So what's changing from 0 to 1 and 0 to 9 to this number here is not the potential, because the potential is always infinite. What's changing is your perception over that potential. And your perception over that potential is geometry. And geometry is symbolic representation. So all of the numbers they are a symbol that represents a structure of geometry in relationship to space. So, and the reason why I think that this is like this is because everything is a multifractal pattern. So you have the same symbols between 0 to 1 that you have between 0 to infinity. You have the exact same symbols. What changes is the way that you organize them. So there's this link between geometry and space-time, which is the symbolic representation of your perception. And mathematics is just mathematics is a projection of your perception. It's not fundamental, I think. So based on these thoughts, it makes me think that the way that I was thinking about is that this line here is not bigger than this line, but the structure that exists is this hierarchical structure. And I think the reason why the hierarchical structure exists is because that's the nature of time. You can't have time if you don't have a hierarchy. So everything is going to connect later, hopefully. But yeah, so you have this. Maybe I should keep drawing here. It's kind of hard to explain because there is a lot of stuff going on, and I know that it's going to be kind of confusing. So this would be like the same thing as doing the reverse process here, but here it doesn't work because, and this is the part that broke my mind, because if you think about it, you can't use like all of the symbols should just capture the meaning on one symbol. There's not enough information to make sense of the stuff that is happening. The only way to make this happen is if you play with the frequency of the symbols. So the conclusion that I got is that symbolic representation is directly connected with two different axes. One is the diversity of symbols. And the other one is the frequency. And this is the relationship that connects both structures on time. So the only difference between this case and this case here is the diversity. Because if you think about it, both of these lines here can go to infinity. You can have an infinity amount of numbers here, or amount of symbols, and an infinity amount of sequence of zeros and ones. So what determines that the only path that makes sense is to go from the binary to the character and not go to from the character to binary. The reason why is because I think that this is the fundamental structure of time, that time itself is the convergence of symbolic representation. Because the boundary of everything is a multifractal structure that goes from the complex plane to the reality. And what this means is that matter can only be defined by the potential, and that is always related to the frequency or the resolution of a geometrical structure. So what is changing is not time. What is changing is the perception of a multifractal structure in relationship to a reference frame that determines the frequency of awareness that creates reality. So the arrow of time is a byproduct of the hierarchical structure of an electromagnetic field, of the coherence of an electromagnetic field that creates a symbolic structure of meaning. So I'm not sure if that makes sense or not. So maybe I should try to, but I'm still not 100% sure about this because there are other things involved, I think. But like, I think that this convergence here, like it's, because if you think about it, like what separates these two different symbols is geometry. So in geometry is a perception that an observer has over the boundaries of something. That's what a pattern is. So when you're using a collection of zeros and ones to represent a character, what you're doing is you're using the contracts of a frequency to represent a more complex geometrical structure, which is an informational field. And the reason why you do this is to maximize energy and efficiency, because the natural tendency of the evolution of information is to create higher and higher and more complex things through this flow of time, which is the way that a network, electromagnetic field, reaches coherence by creating this construction of meaning. Because if you think about it, the only way to make this path work is through the convention. And what is a convention? A convention is the synchronicity of a network of nodes. That's what I think about. So you can only have time if you have a synchronicity of a network of nodes. And that synchronicity creates a hierarchy of meaning, which is the flow of information, which gives the illusion of the perception of time, which is not fundamental. So space-time itself is a consequence of the synchronicity of a network of nodes reaching coherence that creates this illusion that more symbols become complex ones through the evolution of time, because they create a hierarchy, and the hierarchy is related to minimizing efficiency, to maximizing efficiency of the network, because then you can communicate more and more complex things. And this is why I said that at the boundary of everything there is a multifractal, because that's the convergence of time. Because what defines boundaries between things is the simplicity, the perception of simplicity that exists inside of the thing and outside of the thing. And at the line there is a boundary, and the boundary is infinity. And because it's infinity, it doesn't exist. So the only reason why you perceive is because of this hierarchical structure of time, that the convergence of meaning based on the symbols, which is related to the frequency and the diversity. So the flow of time is the evolution of information in relationship to a reference frame that is this connection of the a lower diversity of symbols becoming a higher diversity of symbols, but in reality they have the same level of complexity, which is infinity, which is changing. What is changing is not the level of complexity of the symbols. What's changing is how the frequency of the perception changes over time by maximizing energy over a network. And the network of nodes is the field of the perception. So like is the entire universe, entire reality. And I think that it comes from the complex plane and the complex plane and matter is they're interconnected because it's always a symmetry, because that's the nature of perception. You can't have perception if you don't have distinction, and distinction is a relativistic symmetry. And I think that this is related to space-time as well, because what determines the frequency is the density of space-time. So if you think about it, like zeros, a frequency is just a distinction, and a distinction is the relationship between a reference frame of perception and the relationship between the potential and matter. So potential and matter are two different phases of reality. The potential exists on the complex plane, which is the plane of abstraction or the vacuum. And I think that the reason why this is the case is because the mathematical representation of reality is just the projection of experience. So negative numbers are when you go inside of something. So is the lack of something, which is the potential. And positive numbers are something, which is matter. So when you take the square root of something negative, what you're doing is going into the plane of abstraction or imagination. And the plane of imagination and abstraction is intrinsically connected with the plane of matter because the definition of true are codependent. It's a relativistic symmetry, and that's the nature of identity. So mathematics is the projection of an identity, and through the relationship between the potential and the matter, you have the frequency, and that frequency creates symbolic meaning by the coherence of the electromagnetic field, which is this flow of time here, the hierarchy of concepts. And that's why it seems that the time only goes forward, but in reality is relativistic because the momentum of the network determines the evolution of information. And that's why I think that entropy always increases. It's because in the essence of time, it requires the evolution of information, because that's the momentum of awareness, I think. Is the relationship between the frequencies of the complex plane and matter that creates the frequency, which creates this relationship between symbols, which is the convergence towards a multifractal geometry. And that's the reason why at any given issue, you're always going to have an infinite discussion to reach to the boundaries of the multifractal that make up the complexity of the field. Because the nature of perception itself and the nature of the line is created by the relativistic engagement of the polarity, which is the relativistic symmetries, I think. So what that means is, if you think about it, like, to understand, I think the best way is to think about the extremes. So the other thing that I thought about is that if I don't have zeros and ones, if I only have 0 or 1, let's say I only have 1 to represent something, it's impossible to create any meaning, I think, because you don't have contrasts. So you can't have information if you only have one symbol. And you can go in a deeper discussion because symbols are already a byproduct of the perception, so they couldn't exist if there wasn't a context to define them. But if you're thinking about it, like, without taking that into account, just thinking about the symbol itself, then the only way to represent something with only one symbol is by the frequency, because the frequency creates the contrast. So let's say if you send the signals here, the pulse of the signal would be the matter and the vacuum between them. And then by controlling the vacuum and where the matter is, you have a wave function. And that's the relationship between the complex plane and matter. So here above you would have matter, and then below, which is the stuff that you don't see, is the complex plane, which is imagination. So that's why reality is a self-fulfilling prophecy, but not from the standpoint of the ego that perceives the illusion of separation, but from the standpoint of the multifractal funnel of information that makes up a reality field, which is a coherence of an electromagnetic network. Because that's on itself is the evolution of meaning, and information seems to be increasing, but in reality is always infinitely complex. But it seems to be increasing because that's what defines time, and that's what creates space-time. So if you think about it, it's like you have a box here, and this box is full of water, let's say. Obviously it's not like this, because then the line wouldn't be able to move. But imagine that you have like a plane here, and the plane has a line, and then the observer is inside of the line. So I have someone here observing the line. And this line is a gradient, is an asymptote from the complex plane to matter. Complex plane is potential, matter is what's happening right now. And this line is constantly changing over time through a frequency. And that's a wave function. And then when the line changes from the perspective of the observer, it seems that things are increasing. But in reality, every time that something increases, something else decreases. But from the perception of the observer, it doesn't seem that way. And I think what separates them is death. Like death is a time travel. From that perspective. Because the evolution of time itself is the momentum of the evolution of information, which is the coherence of the electromagnetic field, which creates the symbolic meaning. The structure of symbolic meaning, which is the hierarchy of time. Which you have, at first you only have one symbol, which is the extreme. And this symbol is defined by the frequencies of the wave function, which is this connection between the complex plane and matter. And the evolution of those symbols, which is the evolution of information, is where these two different symbols create other symbols. This is the part that I'm not 100% clear, that I don't know if it makes sense or not. Because yeah, the way that I think it would make sense is because each new symbol that it is created is a byproduct of only one symbol. Like there's always only one symbol. And then that symbol creates all the other ones through the nature of frequency, because this gets encoded into something else based on this variance here of the wave. So over the perception of a reference frame, that's the relativistic nature of space-time, that through the frequencies of this, it creates this convergence towards a multifractal, which is the definition of matter or geometry. Because all the boundaries are in illusion, they only exist over a certain frequency, and that gives the illusion of space and creates the hierarchy of time through the convergence of symbolic meaning over an electromagnetic field that reaches coherence. Because what holds the electromagnetic field together is the synchronicity of the flow of information. So I'm not really sure if any of this makes sense. I think it's like there's still some stuff that I'm trying to clarify, like how that would be the case, like because obviously I think the paradigm of science is wrong. I think nowadays people are evolving in that sense, but like to think that there was a Big Bang and then you're going somewhere I think that already has the assumption of time. So the way that I think it works is not that there was nothing and then there's something. There's always the codependence of nothing is something, because you can only define one in relationship to the other. So the nature of perception is already the relativistic notion of the interaction of these two gradients together. So I think that in order to find the truth, you have to think about something that always existed. So I think what changes is not, because that's the nature of time itself, it's not that you're going somewhere, is that something always existed, and then you have the illusion of going somewhere because of the nature of this thing that always existed, which is, I think, the interaction between the potential and matter. So the evolution of space-time itself, which is the creation of matter, is the relationship between the complex plane, which is potential and imagination, with the actual stuff that is happening, which is matter. And that's always relativistic to the field, to the electromagnetic field, which has a coherence. Because the only way for this to work is if you have a protocol of convention of how do you put meaning into things. And the convention is the synchronicity of the network. And that's what creates geometry, because that's what geometry is. Geometry is the synchronicity of a network, of an electromagnetic network. Because this electromagnetic network is the byproduct of a frequency. And because you have infinite reference frames over that frequency, the synchronicity creates the geometry. And then in relationship to every reference frame, you have differences. You have differences in the way that the frequency, that one symbol, which is just this distinction between potential and matter, it evolves. And then the collection of all the reference frames creates the structure of spacetime, because it is the synchronicity of the network. And the other thing that this made me think about is the process of communication. But this is stuff like I'm not really sure if it makes sense or not, because what this got me thinking is then why do we communicate with words and we don't use binaries to communicate? Because if words are created from simple impulses, and the contrast of those impulses creates the words, because if you think about it, you're not born knowing a language. You learn a language subconsciously, and then you use the language to communicate. So when you talk with people, you don't need to use the simple sounds that create the words. You use the word directly. So when you produce a sound wave, the brain decodes that sound wave into meaning. And if at the moment you were born, you don't know the language directly, that means that there was a process of learning inside of the brain that allows you to decode the message, which is the wave function. So I think that each word, each letter and each word represents a wave function, and the wave function is this contrast that I was talking about, which is a byproduct of geometry. And I think that's the reason why different countries have different languages, because communication itself is directly connected with the nature of space-time, because it's created through the interaction of all the reference frames that creates this frequency of the complex plane to matter, potential to matter, that creates a cohesion on the network. That is this process of communication that builds meaning over time. So the differences in the complexity of space-time is going to determine the evolution of language. And the process that is happening, I think, is that the reason why you don't communicate with simple sounds and you communicate with more complex sounds is because you're subconsciously performing Lagrange interpolation, I think. But I'm not 100% sure if Lagrange interpolation is the correct way to put it. But it's pretty much like adding together different functions. So you can imagine that these symbols here, if you translate, instead of using zeros and one, you translate that into a wave function by representing the amplitude of the wave function through the signals of the zeros and ones. And I think that the way that communication on the internet works is similar to this. let's say you put the time frame constant, and then you represent the values as zeros and the ups as ones. Then if you think about it, this whole process of creating a programming language is you're creating a wave, which is this representation of this, and you're assigning that to a letter. And then you're creating another wave, and you're assigning that to a letter as well. So I'm not 100% sure if it's Lagrange interpolation, the name for this, but when you add multiple different waves, you have a word. Because the process itself is a multifractal pattern, is a convergence through meaning, and that creates the frequency of the wave, which is unique because you're adding a bunch of different waves together, and that creates a unique signature for a sound that compresses information over an electromagnetic field. So if this is correct, I think that it might be possible. And this is the stuff that I'm not really sure because I don't understand how exactly it works. I studied a bunch of the protocols of communication, TCP, UDP. So the way that I think it works is pretty much you send a frame, and then they send a frame back, and then that begins the process of communication. So, but the way that I think it works is that you're sending bytes or bits over the wire, which means that you're just sending the impulses of zeros and ones each time. And I think it might be possible to, instead of doing that, you decode these wave functions into unique signatures, and then you send the wave function instead. And that way, it would allow you to send more complex messages by keeping a convention of the signatures of the wave functions, because it would allow you to compress information. So in the same way that you do the programming with the binaries here, if you instead you create a wave function for each letter, and then the combination of the wave functions are going to be a word, you would be able to, instead of sending all the zeros and ones, you would compress the message because you would send the unique signature of a wave function that represents a letter. But I'm not really sure if that would work or not. And I think the way you do this is by Lagrange interpolation. So you get each word, and then you combine each word by doing Lagrange interpolation over the signature of the functions, wave functions that represent each word. And then you communicate with the Lagrange interpolation, with the functions that were created through the Lagrange interpolation. And then on top of that, the other thing that I still didn't think about really well, but the other component you have to this is cryptography. And this is also a process of the synchronization of the network, because it determines what's the flow of information over the network as well. And I think this is a main component as well that I'm missing here from the explanation that I gave now. Because cryptography and hash functions are like walls. So they also determine this flow of meaning. So I think they are connected somehow with this wave function and symbolic representation. And maybe what they're doing is just somehow blocking this path here. But I have to think more about this to really understand. But I think that this is all that I was thinking about. I'm not really sure if any of this makes sense or not. And I thought about trying to implement this, but I can't. If I do that, I think I'm going to deviate too much from the stuff that I'm doing now. So I already lost a bunch of time thinking about this stuff yesterday. But I think that, and I'm not really sure if it would work or not. And I'm not really sure if it's Lagrange interpolation, the name. Because as far as I think now, fast Fourier transform is to translate a signal into a wave function. So maybe first you perform fast Fourier transform on the binary to transform it into a wave function. I don't know if that makes sense or not. And then you use Lagrange interpolation to sum the functions to create a unique function that you would represent the message you're sending. And then you send the message instead. And if this does work, then you can potentially compress a lot more information, because if you think about it, if there is a standard of message that all the protocols send, so instead of having to send all the standard, you would only send a wave, which would be like a much smaller sequence of zeros and ones, I think, to represent what you're trying to send. But maybe that's how cryptography works, because I remember seeing something on Ethereum on the way the private and public keys work, that they use cryptography and they use elliptic curves to sign the messages. And I don't remember exactly when, but at some point there they use Lagrange interpolation as well, and fast Fourier transform. So I think that it might be the case that blockchains are already doing that, this process that I talked about. But I have to remember how it works to understand. But I think that the reason why this stuff that I'm talking about here is related to AI alignment is because it's related to blockchain, because I think everything is going to come down to that. Because the key to reaching alignment, I think, is understanding how to reach the optimal balance on a network of the power and the communication that each node has. And how do you harmonize the network so that the power that the network gains over time doesn't corrupt itself and destroys itself. And I think that the way you do that is by understanding how the network reaches synchronicity and coherence over the evolution of the symbolic representation. Because that's what defines space-time. Maybe nothing of this makes sense, but yeah. So I think I'm gonna stop here. I'm gonna go over this. I'm gonna try to figure out the rest of the drag events on how to receive the event from Pixi.js instead of receiving the event from the DOM here. So I'm gonna try to see if I can find a function that I can call to. Maybe I'll stop and come back soon today, but I'm not really sure. Because that's the only thing that I have to do left here. And if I can't do that, then I'm just going to figure out a way to calculate the relative position, and I'm going to use that instead. And then after I figure out the drag event, I'm going to study the wheel event, which I think is also going to be really simple. You just change the scale, and then you change all the elements of the canvas based on the scale as well. But yeah, I think I'm going to stop here. Maybe I'll come back today as well to study this, but I'm going to take a break, I think. And I think over time I'm probably going to think more about this stuff here as well, to try to clarify this and see if it makes sense or not. And also to think about this on the context of blockchains and how to try to solve MEV or increase the probability of AI alignment by understanding how networks work. So, see you soon.